Let's solve more exponential functions problems. So in solving exponential functions, it's very useful to familiarize all the law of exponents or the exponent properties. So one useful exponent property is the negative property rule, negative law of exponents rule. You just write the reciprocal. Let's say we're given 1 over a to the power of n. You can just write this as a to the negative n. Okay. Say for example, we're given this problem here. 1 over 9 to the power of 2x equals 3 to the power of 7x minus 1. So we can rewrite 1 over 9 here. 1 over 9 here as 3 to the negative 2. Or can write 1 over 9 as 1 over 3 squared, or just 3 to the negative 2. So this would become 3 to the negative 2 to the power of 2x equals, is this 3 to the power of 7x minus 1. So by using the power of a power rule, we just multiply the exponents here of 3 on the left. So there'll be negative 2 times 2x. So that is 3 to the negative 4x equals 3 to the 7x minus 1. Since both sides already have the same basis, then we can just equate their exponents or set their exponents equal. So it'll be negative 4x equals 7x minus 1. And then solving for x, okay, we subtract 7x from both sides. Okay, this cancels out. So we have negative 11x equals negative 1, and we divide both sides by negative 11. This cancels out, so our x is just equal to 1 over 11. And that is our solution. So if we have several factors with the same base on one side of the equation, we can just add the exponents using the property of exponents. We're given a times, the product rule, a to the n is just equal to a to the m plus n. So you just add the exponents. Okay, say for example, this problem here. We're given 5 to the 4x times 5 to the 2x minus 1 equals 5 to the 3x plus 1. So on our left side, we can just simplify the exponents by adding them up. So 4x plus 2x plus 1. Okay, this would be 5 to the 4x plus 2x minus 1 equals 5 to the 3x plus 11. So that would be 6x minus 1 equals 5 to the 3x plus 11. Since both sides have the same basis, then we can just equate the exponents. It will be x minus 1 equals 3x plus 11. Okay, simplifying. We subtract 3x from both sides. This would be 3x minus 1 equals 11. Then we add 1 to both sides. This cancels out. So we have 3x equals 12. Then we can further simplify that by dividing both sides by 3. So x is equal to 4. So that is our solution. So it may take time, take a bit of practice to get used to knowing which base to use, but as we practice, we will get much quicker and knowing which base to use. So as we do so, we will use our exponent properties to help us simplify. Let's try solving another problem here. So please take note that the exponent properties that are commonly used in solving exponential functions are the power of power rule. Okay, again, so we can just multiply the exponents. The negative rule, so you can write that as a to the negative n, and then the product rule. Okay, so we just add the exponents in that case. Okay, let's try solving this problem here. So we're given 16 to the power 2x minus 5 times 1/4 to the 3x plus 1 equals 32 times 1/2 to the x plus 3. So how are we going to solve this? So we have to write everything in a common base. So we need to simplify first those that are in the parentheses and those that are fractions. So by using the negative exponent rule, we can write 1/4 as 1 over 2 squared, or 2 to the negative 2. And then 1/2, we can write this, because this is just 1 over 2 to the 1, we can write that as 2 to the negative 1. Okay, so we write this, we copy 16 to the 2x minus 5 times, this one is 2 to the negative 2, the 3x plus 1 equals 32 times 2 to the negative 1 to the power of x plus 3. Okay, so it seems that 16 here and 32 are also divisible by 2. So we can just conclude that our base here would be 2. So we can write 16 as 2 to the 4th. So it'll be 2 to the 4th to the power of 2x minus 5. And this one we simplify by applying power of a power rule. That would be negative 2 times 3x plus 1. So that is 2 to the power of negative 6x minus 2. Okay, equals 32 can be written as 2 to the power of 5 times, okay, simplifying this, it would be 2 to the negative x minus 3. Okay, by applying the product rule, okay, since they have two bases, we can just multiply, or we can just add the exponents. So first we have to simplify this. This would be 2 to the 8x minus 20 times 2 to the negative 6x minus 2 equals 2 to the 5th times 2 to the negative x minus 3. We can add the exponents. That would be 2 to the 8x minus 20 plus negative 6x minus 2. Okay, 2 to the 5th plus negative x minus 3. So this would be grouping like terms. 8x minus 6x, that would be 2x. Negative 20 minus 2 is negative 22. And on the right side, 5, we group 5 and negative 3. So that is 2 to the negative x. 5 minus 3 is 2. So that is 2 to the negative x plus 2. Then simplifying this further, 2 to the 2x minus 22 is equal to 2 to the negative x plus 2. Since the two sides, both of the sides are have the same basis, then we can just equate the exponents. It would be 2x minus 22 equals negative x plus 2. Then simplifying this one, we can just add x to both sides, so this cancels out. So this is 3x minus 22 equals 2. And then we add 22 to both sides. Okay, this cancels out and we're left with 3x equals 24. Dividing both sides by 3, then we get our x as 8. So that is our solution.